It begins as a contradiction in the dark, a point of heat drifting where sunlight cannot reach, a whisper of mid-infrared against the cosmic microwave hush, as though something out there exhaled warmth into a vacuum that should only take. We are used to the sun being the great accountant of temperature, adding and subtracting by the simple geometry of distance. Double the distance, quarter the light, and the night grows accordingly. But here, long before the golden flood of daybreak could touch it, the object we now call 3I Atlas glowed like an ember cradled in an unseen hand. Astronomers have words for most things, even the beautiful ones, but for a moment the language failed. The numbers were calm, the instruments faithful, and yet the picture they painted was outrageous. An interstellar traveler, cold by expectation, warm by fact. You could almost feel the universe lean closer, as if to listen to the slight crackle of thermal photons rise from a body sworn to darkness. That first detection came with the texture of disbelief, the kind of disbelief that doesn't deny, but kneels, that pauses not to reject, but to record. Here was an emissary from another star, a messenger in its own native tempo, and the message was heat. We named it with tidy human order, cataloging it as the third interstellar object on record, tying it to the survey that first teased its path from the noise. Names are how we pretend we are not lost, but no label could domesticate its trajectory. Its motion wrote a hyperbola across the pages of the solar system, an open curve that refused a return address. Its speed, even far from the sun, belonged to another neighborhood of the galaxy, a remnant of birth in a different gravitational cradle, a momentum sealed by a different dawn. Telescopes raked the sky for every clue that the faint visitor would yield. The visible band stuttered with slightness. The infrared, however, sang. It was not a shout, this was no furnace, but a clear, steady note, too warm for the absence of light, too persistent for the stingy calories radiated by interplanetary dust. The paradox sharpened our attention. We spun models like silk, simple ellipsoids turning in black space, then fractured geology, then fractal porosity, each with its own set of conductivities and emissivities, trying to solve the equation whose answer dared us to admit the strangeness of far-off places. The data wanted a story. Photometry stitched in long winter hours showed a rotation that never matched the temperature swings we expected. On ordinary comets, day and night are violent opposites. Sunlight slaps a surface into sudden fever. Night drops it like a stone into Arctic sleep. But 3I Atlas seemed untroubled. Day did not scorch, night did not punish. Its curve of heating and cooling flattened into the calm of something with a memory, as if its interior remembered warmth and returned it on schedule. Spectroscopy, the art of taste and touch with light, offered no simple solvents. There were hints, broad, shy signatures that might be silicates rattled by cold, or carbon stitched into labyrinths, perhaps a film of complex organics. No bright emission lines shouted steam. If there were jets of gas, they were subtle, more like the breath through a reed than the plosive cough of cometary outgassing. And through it all, the thermal peak drifted too high, an apparent black body that refused to be a body colored only by the black of space. We kept subtracting the sun and the numbers refused to lower. We kept adding conduction paths and the numbers refused to rise too quickly. Somewhere between lies a material, a structure, or a trick we have not yet seen. In the mechanics of motion, the object bent to gravity with the polite obedience of a stone. And yet, there were whispers of disobedience. When you fit its path with pure gravitation, solar mass at the focus, planetary tugs accounted for, the residuals did not vanish into the numerical foam. They remained small but patient, like the faint wake behind a slow oar. Non-gravitational acceleration is not a taboo. Comets act this way when jets push them from their perfect ellipses. But comets advertise their habit with spectral flare, a chemical confession in light. Here the confession was missing or muttered. The curve of acceleration, too, was odd. Not a burst, not a single shove, but a long caress, as if the object negotiated with the vacuum in whispers. Solar radiation pressure can push sail-like surfaces if you give photons something broad and light to lean on. That, too, leaves a trace in the balance between mass and cross-section. If 3I Atlas carried a skin tuned to catch the faint fists of light, it was better at secrecy than we were at seeing. Too massive to be a toy balloon, too responsive to be granite drift, it sat in a place between, taking what little the sun offered and somehow multiplying its effect. To make sense of warmth, where light is rationed, we reach for the chemistry of the intimate. Think of ultra-porous matrices, sponges of ice and carbon, where heat doesn't simply pass bus. T lingers, trapped in microchambers that slow its escape, a thermal maze whose exit is deliberately confusing. Think of phase changes not as singular events, but as choirs, where 1,000 micromelts and refreezes pace the release of energy with a steadiness that mocks the cold. In the bones of some meteorites on Earth, we find tiny grains that sing of radioactivity from ancient stellar forges. Their voices are quiet now, but scaled to a body left alone in the dark, the warmth could be meaningful. Or think bigger, a stratified shell where emissivity is not a constant but a policy, where the surface is draped in materials that absorb greedily and radiate reluctantly, a thermal diode that favors inward retention over outward loss. It sounds like engineering, and perhaps in some future age we will make such cloaks to nurse our long-range probes through the desolate geometry between stars. But nature, with her endless patience, can build devices by accident that we only arrive at by design. Somewhere far away under another sun's formative tantrums, a small world could have grown a skin of peculiar cunning. Speculation sharpens when coincidence arrives, and the sky conspired to offer us a few. As if by appointment, the object's most puzzling thermal behavior bloomed during a corridor of low solar activity. The heliosphere's breath slowed. The space weather turned from drama to chamber music. Even the geometry of Earth, Sun, and the Traveler stacked in a way that gave us clean lines of sight during particular spin phases. The effect might be chance, and yet chance often looks like choreography when our sample size is 1. In our business, we are wary of conspiracy. Nature rarely needs it, but timing matters in physics. If the object's interior had a rhythm, a long-time constant, then the muted storm of the sun could have allowed its own cycles to declare themselves without interference, like a heart overheard in a quiet room. The alignment of our telescope's availability with those pulses made the impression stronger still. Coincidence is not proof, but it is motive. It drives us to test, to model, to refuse the easy peace of unknown. Gravity, that craftsman with a taste for curves, did the large-scale sculpting. The object swept into the solar system on a trajectory that never needed permission to leave. Its eccentricity wore the number 1 as a border to pass and did not look back. As it descended into the inner realms, Jupiter's web tugged at its sleeve, not enough to capture, but enough to make a delicate stitch in its path. We mapped the encounter in the B-plane, that mathematician's cross-section through the future, and found the missed distance close enough to make every dynamicist lean forward. If you subtract everything we know, planetary masses and their ephemerides, the sun's oblateness radiation pressure, what remains is the choreography of something else. A micro-thrust aligned a little too often with the direction of travel. A thermal force that felt more like the Yarkovsky effect's urbane cousin than a comet's riot. Perhaps the object's shape was not the friendly potato we often draw, but something flatter, more cunning to torque. A slab, a shard, a petal, each would rotate under sunlight to favor one face over another, letting heat build asymmetrically, venting momentum in ways that do not declare themselves in the spectrum, but leave a fingerprint on the orbit. The solar system has always been a school for dynamics. 3I Atlas became a pop quiz. Then came the silence, and with silence, stories. Observations near solar elongation are as hard as looking for a firefly beside a searchlight. Our instruments are heroic, but geometry is tyrannical. The sun swamps the field, and the object passes behind a curtain we cannot lift without burning our eyes. For weeks, then a month, then more, the data thinned to guesswork and patience. In that absence, rumors found oxygen. Some swore that classified telescopes had kept watch and locked the data behind badges, that the thermal profile sharpened into intent and the intent into design. Others whispered that calibration had betrayed us, that early readings were tinted by a hot pixel masquerading as alien geology. Most of us waited, fingers on proposals, eyes on scheduling committees, hearts making vows to the next window of visibility. Silence is not conspiracy. Often it is merely the architecture of orbit. When the object slid free of the sun's glare and into view again, our instruments breathed out. The warmth remained, quieter, altered by geometry and distance, but real. If there were secrets in the blackout, they were the same old secrets of orbital mechanics, which still delight in their power to hide and reveal. What it means, if it means anything beyond its own particularity, is a doorway. Imagine deep space craft that survive not by gluttony for power, but by thrift, wrapped in skins that learn from night, materials that sip photons at the edge of interplanetary space and convert those sips into hours of buoyant warmth, reducing the mass we must carry as propellant, the watts we must demand from a distant sun. Think of probes that sequester heat from radioactive hearts with clever gradients, releasing it not as waste, but as carefully timed impulses that nudge trajectories almost invisibly. The argument is not that 3i Atlas is a machine. The argument is that it teaches the tricks machines could use. The chemistry of porous carbonates and organics, of amorphous ices that relax slowly, of micro caverns that trap energy on purpose or on accident, these become a catalog not only of planetary science, but of engineering options. The future of outer planet missions could inherit what this wanderer implies. And if on some fractal edge of probability we were seeing a relic of someone else's craft, weathered beyond all clear signature down to the modest behavior of a well-designed thermal coat, then the implication is gentler and greater, that engineering converges. Many minds under many suns might solve the cold in the same handful of ways. We are already sketching a response befitting the age. Constellations of infrared sentinels parked in high Earth orbits or farther out at Lagrange points can keep continuous vigil for anomalies without the seasonal blindfold of elongation. Quick-launch interceptors born from a modular stable could sprint to meet the next interstellar wayfarer and play the oldest scientific game of all, go there and measure it. We picture a swarm rather than a single ship, a cloud of shoebox craft that thread the object's near vacuum with tiny interference mapping the thermal landscape like bees learning a meadow. One could trail a laser across its surface to watch how heat migrates. Another could inhale the faintest dust to learn the alphabet of its chemistry. A third could stand off and listen to the whispers of non-gravitational acceleration as if decoding a heartbeat. The lessons would not be trivia. They would calibrate our models of how solids behave in the jostling of starlight, how frost and rock and carbon masquerade as systems. And somewhere in those lessons, we will find a blueprint for ships that take their warmth with them not as burden, but as choreography. None of this must become myth to be meaningful. The romance of an interstellar visitor is real, but it should not seduce us away from the discipline that made the romance audible. Our error bars matter. Our uncertainties are not confessions of failure, but the proper contour of the unknown. When the numbers disagree, the universe is inviting us to widen the sentence. Perhaps the interior of 3i Atlas was a snow of aerogel-like pores. Perhaps it carried grains kissed by ancient radionuclides. Perhaps its skin was a tapestry of organics that learned to be dark in sunlight and shy in emission. Each perhaps is a bridge. If we are careful in our construction, we can cross. If we are reckless, we fall into stories that comfort rather than clarify. The path forward is both old and new, patient observation, rigorous modeling, and the humility to let the object be what it is, not what we hope or fear. There is grandeur in that humility, a beauty that does not need decoration. The universe does not perform for us. It continues, and we are lucky to catch it in the act. So we end where we began, with heat and night, with an ember that should have been ash. In the great arithmetic of the cosmos, energy is the master's signature, conserved and transformed, never invented from nothing, and never lost to nowhere. 3i Atlas forced us to look more closely at the ledgers we keep, to consider that the columns of conduction and radiation and phase change might have sub-accounts we have not opened. It was a visitor that asked for hospitality, not in attention, but in imagination. And our reply, if we are worthy, is to build instruments that see what we could not, missions that go where we have not, materials that behave in the ways we once believed were reserved for myth. The discovery does not prove that minds beyond ours have passed here, but it proves something nearly as precious, that there are still surprises in the old theater of physics, mechanisms waiting like dormant seeds for the right season of curiosity. When the next interstellar body arrives, we will be riches, with a different kind of welcome, one that honors heat where we are sure there should be none, one that knows how to listen when the night itself seems to glow. In the far future, when our descendants walk ship hulls that coast for centuries through the thin light between stars, they will have solved the same problem in miniature that this wanderer hinted at in passing. They will wear the night like a clever garment. They will tilt sails whose physics we now practice only in thought. They will carry reactors as quiet as a stone's breath and fabrics that bargain with photons. And in their libraries, if libraries are still a concept, they will keep the stories of the first emissaries from other suns whose gifts were questions more than answers. That is how science grows tall, on questions that feel like myths until mathematics teaches them prose. The glow in darkness that greeted us was not an omen, it was an invitation. The universe held out a lesson in the small, all while moving continents of gas and time around it. We took the lesson imperfectly, as we always do, and pledged to learn the rest when the sky opens again. In the meantime, we keep watch. The arrays hum in the cold, eyes set to the hues where warmth will betray itself even when light will not. Software that grew up on exoplanet transits and asteroid surveys now listens for the odd cadence of a thermal curve that refuses to obey the inverse square with proper deference. Proposals draft themselves upon the desks of committees whose only real loyalty is to curiosity. Students learn the names of phenomena that did not exist for their teachers, and then they move the names around to see what new sentences are possible. Somewhere beyond the Kuiper Cliffs, beyond the thin halo of comets that encases the solar system in a fuzzy crown, another fragment of somebody else's night begins to arc toward us, buffeted by the weak handshake of gravity between stars. It carries its own instructions, written not in glyphs but in behavior. It is indifferent to our calendars. But it comes, and our readiness will be measured in how quickly we can translate motion into meaning without breaking the poetry of what is. You can hear, if you listen, a very quiet optimism in the laboratories where heat capacity is measured grain by grain, in the clean rooms where fabrics are spun from equations, in the control rooms where a single pixel's honesty is a matter of faith. The optimism is not arrogance. It is a defense against despair, a wager that the universe is comprehensible in chapters, if not paragraphs. We do not need to know everything to know something. We do not need proof of others to prove ourselves capable of subtlety. The gentle acceleration that teased the orbit of 3i Atlas was not a trumpet. It was a fingertip on a glass. The resonance it produced vibrates still in the models that now dare to mix geology with design, that allow that nature can wear the mask of mechanism and mechanism the mask of nature. These are not two kingdoms. They are one empire under different skies, ruled by consistency and crowned by surprise. And if there is a philosophy to carry from this, it is neither resignation nor conspiracy. It is a simple bravery, to greet the unknown without surrendering to fantasy, and to defend wonder with work. The cosmos is old and unhurried. It is under no obligation to place its most interesting riddles where we can reach them easily. Yet sometimes it does, and it did, in the form of a warm stone in a cold place. We answered as best we could, and in doing so, we built the first pages of a manual for living in the dark. One day that manual will be a child's textbook, unremarkable and dog-eared, and children will wonder how anyone found these ideas difficult. This is the trajectory of knowledge, as open and onward as a hyperbola that has learned to play the part of a path. The traveler is already gone, outbound toward the coordinates where our math loses interest and our hearts do not. It leaves behind no artifact, no sample jar in a museum case, only the thin fossils of light we caught while it passed. Those fossils are enough. They contain in their strata the first impression of a new family of behaviors, a biology of the inanimate, a way that matter remembers warmth and uses it with talent. Long after its photons have merged with background starlight, the consequences of its visit will grow into instruments and voyages that could not have existed before. In that sense, the object has altered our future by the gentle force of curiosity alone. A culture is shaped by what it finds worth noticing. We have chosen yet again to notice the faint, the odd, the quiet. We will be rewarded for that choice, not with a revelation that answers all questions, but with a cascade of better questions that will prevent us from ever being bored under the night again. And if somewhere, sometime, we have the fortune to meet a mind not our own, I suspect this will be among our first shared smiles. That we both prized heat in the cold, that we both learned to bank the ember and ration the flame, that we both traced destiny on hyperbolas and found poetry in the math. Until then, we are left with the best companion the universe offers, uncertainty, and the best tool we have forged, patience. The sky is full of travelers. We are finally fast enough, clever enough, and reverent enough to greet them properly. The old story said fire was stolen from the gods. The new story says it can be borrowed from the dark. And in that borrowing, in that simple act of honoring a warmth that should not have been there and yet was, we become a little more native to the cosmos that made us